At first, we should learn about the nature of light. Actually, light has dual nature. One is a particle nature and one is a wave nature. So, we have learned about the two nature of light. Okay. Until the time of Isaac Newton, the most scientists think that light consists of streams of particles that's emits by the light source. Okay. Now, after 1873, James Clerk Maxwell actually discovered the electromagnetic theory. Maxwell discovered electromagnetism. To describe the properties of light. But actually some properties like the absorption and the emission of light doesn't explain by the wave nature of light. So according to Maxwell, light is a propagation of electric and magnetic fields which is perpendicular to each other. So I draw the picture, and this is our electric field, this red color, and this blue color is our magnetic field, and we can see that they are perpendicular to each other, and the direction is exactly with the direction of vector product E cross B, where the E is electric field and B is magnetic field. So this is our electromagnetic architecture we actually draw. But various properties of light cannot be explained by these properties of electromagnetism. It is a property of wave theory, the wave nature of light. So some properties like the emission and absorption, like the absorption of light from the surface of metal which can generate heat, cannot be explained by the wave nature of light. So what is the particle nature? Actually, the particle nature of light, say particle nature of light is actually two types. One is particle nature and one is wave character. Okay. So what is the particle character or particle nature? It is actually says that light is consists of a elementary particle which is say the photon. Scientists saw that the light carried energy which is a packet of discrete bundle which is called the photon. Light carried energy of discrete bundle called photon. This photon is actually a quanta. Okay, it is an elementary particle. It has some special properties. It is not like the atoms, it is not like the protons or neutron. It has some special character, so it makes it special. So what is the character of photon? It have zero rest mass. It has zero rest mass. It's never be created, destroyed or separated. So photon is ultimate. Okay, and this zero rest mass, because of this zero rest mass, light can get its ultimate speed, because in the universe light has only the fastest speed, which is about c is equal to 2.99 792458 into 10 to the power 8 meter per second. This is the exact value of light, which can be approximate into 3 into 10 to the power 8 meter per second. And all the math problem can be solved with this value of light speed. Okay, so this is our wave character and particle character of light. There are two fundamental sources of light. Okay, there are two fundamental sources. One is the electromagnetic radiation, which is called the thermal radiation. Many of the cases we actually know that this was occurred by thermal radiation. Thermal radiation. Any object which has temperature more than 0 Kelvin, the ultimate temperature of the universe is 0 Kelvin. So more than 0 Kelvin is emits the radiation, which is called the thermal radiation. And the second is it is produced by the electrical discharge. Electrical discharge through the ionized gas. Through the ionized gas. It is like example of the sodium vapor lamp. Okay, sodium vapor lamp. And thermal radiation we can see everywhere. We actually emits the thermal radiation, but our eyes is not the sensitive with this radiation, so we cannot actually watch this thermal radiation. But some animal and some reptile in this world can't watch actually thermal radiation, like the snake. Okay, so how the light is produced can be explained in two ways. One is macroscopic level and one is microscopic level. Okay, microscopic level and macroscopic level. Okay, so macroscopic level is the example of thermal radiation. Every accelerated charge actually produce the electromagnetic radiation, electromagnetic rays. So the first condition is to be the accelerated. Okay, if the charge is move with a constant velocity or the charge is stationary, then it never produce, it actually produce the electric field. So when the charge is accelerated in some medium, then it actually produce the electromagnetic radiation. So when the charge actually accelerated, when we give heat to it, give heat or thermal contribution to this surface. Okay, give heat to the surface, then the movable charge, the charge which can move through, can accelerated and produce the electromagnetic radiation. And in microscopic level we know that every particle consists with atoms. So if we draw a model of atoms, it is like this, and electron is the surface outer shell. So when an electron changes orbit from higher orbit to lower orbit, it actually emits a radiation. This radiation actually the exact value of the energy gap between two orbit. Okay, so the value of the radiation, by value of the energy of the radiation, is exactly the energy gap of two orbit. Okay, as we learn about the geometrical optics, so we have to learn the ray model of lights. Actually in ray model of lights we actually know that we make some assumption, that simple assumption, that light travel from the source in straight line. Okay, so actually when we do some math problems or go through the geometrical optics, we have to know that light is go through the straight line. Okay, it is actually a ray model, so it is the source and light is go through like this in all the direction of the source. Okay, actually a point source emits a light ray which is spherical in this wave front. Okay, second is light can reflect from the metal surface. From metal surface. Okay, so we also learn why the metal surface actually reflects light, because in the first we saw that light has a two components, which is electric field and magnetic field. So a metal surface is a perfect conductor. Okay, a perfect conductor means it can produce a electric field, then it's spread through the conductor. Okay, so this is our metal sheet. Okay, this is our metal sheets, and this is the light which come from any source strike on the metal sheet, and what is happens between the strike point of this metal sheet, the electric fields can travel through the metal sheet. Okay, because the metal can conduct the electricity, so this electricity can be generated throughout the metal sheet, and this electric field also generate a magnetic field, and this electric and magnetic fields can generate a electromagnetic rays of same intensity. When the same intensity will occur, when this will be a perfect conductor. So for a perfect conductor, the intensity of incoming ray will be the same of the intensity of the outcoming ray. Okay, so this frequency and this frequency will be same, the wavelength also be same, and the intensity will be the same for the perfect conductor. So the light can reflect from the metal surface. Actually it is not all metal surface, it is the perfect conduct, it is for the conducting surface which can conduct the electricity. And third point is it also propagates through vacuum, air and glass etc. So light can also propagate or travel through vacuum, air and glass etc. So light can travel some optical medium. Okay, but the light velocity will not the exact value of 3 into 10 to the power 8, because the 3 into 10 to the power 8 meter per second is just for the vacuum. When the optical density of the medium will increase, the velocity of the light will be decreased. We have to remember this. So the optical density can be also just equivalent and can be also the refractive index. Okay, so what is the refractive index? Refractive index, actually the ratio of C by V. C is the velocity of light in vacuum, velocity of light in vacuum and v is the velocity of light on that medium. Okay, so the ultimate speed of the light is based in vacuum, so it will always be greater than 1. Okay, so we can use like mu to express the refractive index. Okay, reflection and refraction, we use the ray model of light to explore the most important aspect of light propagation, the reflection and refraction. Use the ray model of light to explore the most important topics. Okay, we actually use the ray model of light. Actually, reflection is two types. Okay, it's two types. One is specular reflection. And second is diffuse reflection. Diffuse reflection. Okay, so what is our specular reflection and what is the diffuse reflection? When a surface is very smooth, then the specular reflection occurs. Actually, specular is come from the Latin word, okay, which means the mirror. The mirror, the smooth mirror is very smooth. So in the case of mirror, the specular reflection was occur. And other case, when we actually read the books, then the specular reflection was occur, because specular reflection is ideal for some things watching, because it doesn't need some special angle to watch the full body. Okay, but in the case of specular reflection, we have to maintain the position when we actually look some object. Okay, so in this case, when a parallel beam strike on the surface, so of a specular very smooth surface, then the reflected rays also parallel. Okay, and it's also hold the properties of the reflection, which we discuss later. Okay, and in this case, it also maintain the properties of reflection, but in my macroscopic level, it seems that it violates the properties, because there are very level and there are many planes which is not smooth, and every plane actually curve or different angle. So when a parallel beam strike on the surface, this is incoming rays, then the outcoming rays is not the parallel to each other. Okay, this will be like this. Okay, and this is ideal for watching some things. Okay, let's know about the refraction. Okay, refraction. Suppose this is a glass slab. Okay, and a ray comes from the air, so the refractive index of glass slab and the refractive index of the air must be different, because the velocity will be different. Okay, we have to remember, if have to make some angle with the normal. It is not the perpendicular with the surface. Okay, so let's make some angle with normal, strike on the surface of the slab. Okay, this parallel light beam strike on the glass slab. Then what occur? Some beam will be reflected from the surface. It is the some part of this light, so we have to know that the intensity will not be the same. Okay, some part will be reflected and some part will goes through the slab. Okay, but it will not the same direction which is come actually. Okay, this will occur. So we can see the angle here is less than, okay, so it is theta A, theta B. So we can easily notice that theta A greater than theta B if NB greater than NA, where the N is refractive index of this medium. So why such a incident occur? Because actually light travels here the velocity of almost c, but here in the glass slab is not exactly the velocity of the vacuum. So keep the light in same, okay, same phase. The light actually reduces angle with the normal when it enters in the glass slab. Actually it is for keep the same phase. Okay, so to keep the same phase, the refraction will occur. Okay, if the same phase was not maintained, then we actually not notice the same light. We can see the any other color of light which is actually not a strike on the slab. Okay, so this is occur. Let's we discuss about one of the most important laws. Okay, the laws of reflection and refraction. There are actually 3 laws. Okay, so what is the first law? Okay, the incident ray, the reflected ray, the refracted ray and the normal of the plane will lie in the same plane. Okay, incident ray, reflected ray and refracted rays. I actually take one ray for simple. Okay, ray and the normal of 2 surface will be in the same plane. If this page is a plane, then all is lie in the same plane, because I can draw all this picture in the plane. Okay, so actually we say about some things about my picture. This is material A and this is material B, which is get together. Okay, and a incident ray which is at first in the material A strike on the surface between material A and B, and a reflected ray which is this. Okay, refracted rays, and this is our reflected ray. Okay, so this is the first law of reflection and refraction. And the second law, the angle of reflection, this is the angle of reflection theta A, and the angle of incident ray with the normal will be the same. Okay, if the angle of reflection angle of reflection is equal to theta. Angle of incident ray with normal is equal to theta A. Then the laws of reflection can say that theta R is equal to theta A, or these two angle will be same. The laws number 3 for monochromic light. Okay, monochromic light means the light which is the same color. Actually same color means the same wavelength, same frequency. Okay, for monochromic light, and for two material, okay, which is given for two given pair of material, for two given pair of material, okay, A and B on opposite side of interface. This interface in opposite side, okay, opposite side of interface. The ratio of sine of angle theta n and theta b will be the inverse of two index of refraction. Okay, the ratio of angle, ratio of sine angle of theta a and theta b will be the inverse, will be equal to inverse of refractive index of two given material. Okay, so in mathematically, sine theta a by sine theta b is equal to nb by na, or simply we can write na into sine theta a is equal to nb into sine theta b. Okay, this is the also called the Snell's law. Okay, the laws of refraction, this is called the laws of refraction or Snell's law. Okay, so this is the laws of reflection and refraction. This is three laws which is one of the most important topics of this chapter. Let's know about how to solve a problem with reflection and refraction, may be asked in algebraical expression or in a numerical answer. Okay, now to solve an answer we actually draw a model. The model is called IC. For every mathematical question we actually use the model IC. I actually identify the relevant concept. Okay, identify the relevant concept Okay, now we actually what is know about the identify about the relevant concept. In this topics, in this section, we actually identify the target variable of the problem. Okay, the target variable of the problem, and also make a list about the given quantity. Make a list about the given quantities. The quantities which actually asked. Okay, in this section we actually use the geometric optics. Use the geometric optics. Okay, know whether the light is reflected. Okay, whether the light is reflected or refracted. Okay, so it is the first, and second C is set up the problem. Set up the problem. Okay, in this section we actually draw a neat diagram. Draw a neat diagram. Actually I draw some diagram of the material A, material B, and reflected ray, refracted ray, incident ray. Okay, so we actually draw a neat diagram. The diagram should be large scale. Diagram should be on large scale. We not draw actually a small picture. Okay, we should draw a large picture. Large is not exactly these types of large. Okay, it is medium large picture. Okay, and identify also the target variables. Okay, we label the angles index of the refraction. Label the angles refractive index. Of the medium. Okay, we actually set up the problem like this. And number 3 is execute the problem as follows. Okay, execute the solution. The solution. In this section we actually do the math. Okay, do the math here. Okay, we can apply the laws of reflection, apply laws of reflection, refraction with respect to the normal. Okay, second, use the trigonometry. Use trigonometry and geometry. while solving this problem we have to use the properties of triangle, the properties of complementary angle, so we have to use the geometry and trigonometry together. Okay, and third, we should learn, we should memorize that the frequency of electromagnetic radiation does not change. Okay, so frequency will remain constant. We have to remember this, that frequency will remain constant irrespectively what the medium actually is and from where it travel from another medium to others medium. Okay, but the wavelength will be changed, but the frequency of electromagnetic radiation does not change when it moves from material to another. Okay, so the third point is have to remember this and evaluate. Number 3 is 4 is evaluate. Evaluate actually knows whether my answer is correct or not. Actually, to know whether my answer is relevant, is it real or not real, is it practical, we have to ask question ourselves that is it make sense, our answer makes sense. If sometimes the angle will be so large that it doesn't make sense, so we have to evaluate the problem. We also note if the refractive index Na greater than Nb, then theta p greater than theta I. We have to know some types of math, okay, to evaluate our answer. So in this section we should also know about whether our answer is correct or not. Okay.